So you have about 3 more minutes to complete solving. Go to another problem, you have to do one of those. Okay, Kevin, you did 2 problems. Now I want you to start thinking about these questions once they're gone. You're gonna, once you finish both questions, you're gonna do the think part on your own. The first question it says, what is the difference? What are different about these? What is different about these equations? What is different about these equations than the ones we learned on Friday? And then you can answer question number 2. Okay, try another. Okay, once you've finished, like I said, solve both problems, you want to start the think portion of the think, pair, share. Okay, 1 more minute, and I'll need everybody in their seats so we can start our think, pair, share. So everybody, now that you're back at your seat, make sure you're doing the next part. Make sure you just bring over the number exactly the way it is. Okay, everybody back at their seats. Everybody back at their seats so we can start doing our think, pair, share. Right now, everybody should be thinking, what is different about these equations than the ones we dealt with on Friday? And what are the similarities and differences between combined like terms and distributive properties? What are some of the similarities and differences of combined like terms and distributive property? It may be something as simple as just talking about what they both do to an equation. Well, okay, so I want you to take time to think about that and answer at least one of those questions. What is different about these equations, and what are the similarities and differences between combined like terms and distributive property? You have 1 minute to respond, and then we're going to do our pair part. Okay, so now, I want you to pair up. Even if you haven't finished writing because you were finishing up your problems, you're fine. You still can answer the question. I want each table to discuss those 2 things we just thought about. What is different about these equations? So everybody should be discussing. And what are the similarities and differences between combined like terms and the distributive property? Let's start discussing. Just write that. Talk about it to each other. What did you notice differently? Okay, sorry, y'all finished discussing because I don't hear this start discussing. Okay. Let's go to the pair part. Write down one thing your partner noticed that you did not. Write down one thing your partner noticed that you did not. So you write down one thing you noticed that your partner did, or your partner noticed that you did.
So we got to let each other question and
I
problem.
mean, she just shared our response. What did you say, David?
I said they both had something to do with solving equations, and these equations have multiple steps versus the one we learned from last week.
Very good. What else? Did you notice something different?
No. I think it was longer.
The problems take a little bit more, right? Steph?
Yeah.
All right, so let's share out. One thing that you noticed or that your partner noticed that you did not. So I need somebody to share out. Whatever you guys discuss, give me one thing on this side and one thing on that side, and we're going to move on. So this side wants to share out one thing they noticed about these problems.
On this side, they deal with distributed property.
Okay, this side dealt with distributed property, so you knew you had to handle that first before you started solving the equation. How about this side?
This side, combined terms.
Okay. So what's similar about these?
You're adding my term.
You're adding like terms. Okay, so you may have to add like terms in the distributed property problem. You may have to add. You definitely have to do it in here. So what else is different? What's similar?
They're both, they broken down to two-step equations.
They both break it down in two-step equations. Very good. So they both are used to kind of simplify your problem. And they both need to be done before you even begin to what? Solve your problem. So that was the main thing about this particular activity. Anybody else have anything to share before we move on? All right, so we're moving on to the mini lesson part of our lesson. We completed our exploration activity. Our mini lesson is just basically going and kind of adding to the steps that we learned on Friday. Friday we learned how to get rid, and we're going to add some more steps to our get rid strategy. I need somebody to read the objective that is on the Cornell notes that we're going to cover. It's right here. Somebody read the objective on the paper so we can go through these notes.
Students will be able to use the get-rid strategies to solve multi-step equations that include distributed property and combined like terms.
Okay, so students will be able to use the get rid strategy. What do we know about the get rid strategy already?
It involves getting rid of what you get rid of to solve the problem.
It involves getting rid of whatever you need to get rid of in order to solve the problem. Excellent work. Read the essential question in Tajon.
What steps are needed to solve multiple step equations? How does the distributed property and combined like terms make solving equations easy?
So we want to know, one of the essential questions is, what steps are needed to even solve multi-step equations? And we noticed that there are some steps. We noticed that we might have to use what property? And we noticed that we might have to do what? Okay, so those are some things that we're adding to our list of getting rid of some things. So, how does the distributed property and combined like terms make solving equations easier? I think we just kind of discussed that earlier. Take your time to quick write. In the box that says quick write, it says, when solving expressions, we use the order of operations. Why are the steps reversed when solving equations? When we solve expressions like 5x plus so the first thing we would do is what? Divide, because that's what the order of operations tells us. But why is it different when we're solving equations? Why is it different? Why aren't we multiplying first? Why am I adding and subtracting first? Why do you think that those rules have been reversed? Write that there. What do you think the reason is before we begin? Take 30 seconds to finish writing, and then we'll have somebody share out. somebody other than Deja. Deja, you can share out yours, but I want to have somebody else and you just add on to what they're saying. Anybody else want to share theirs? Why do you think the operations, the rules have been reversed? Okay? Davon, you want to try it out?
I put learning has an equal sign.
Oh, when you have an equal sign, guess what that brings? What's that I word?
Inverse.
Meaning,
Do the opposite.
so that's why we're doing what?
The opposite.
The reverse, okay? Because we're going to solve backwards, because we're trying to find something. So we need to work backwards, so that's why we're using reverse. Because normally with order of operations, we're just using the signs to tell us, okay, I see parentheses, let me do that first exponent. But with equations, we're looking for this, so we have to work backwards. So doing the reverse and doing the opposite and there's the equal sign, very good. That's what I'm looking for. Moving on down. What is the get-rich strategy? So we're going to learn the get-rich strategy. We've already knew 2 steps. But we're now moving those steps all the way down to the bottom. So the first thing you get rid of is somebody read step 1.
Get rid of fractions.
Okay, write it down. Step 2, Kevin. Get rid of the parentheses. Step 3, Timothy.
Get rid of like terms.
Step 4, Deja.
Get rid of the constant.
Tajon, step 5.
Get rid of the coefficient.
Coefficient. So I need you to take your time to write those steps now. Okay, so now that we have our steps, we're going to walk through the steps together. When you have fractions, you can multiply by a common denominator and get rid of that fraction, but we're not going to really get into that today, but I did want to give you that step because we'll address those tomorrow. So, the first step is to get rid of the fraction. So what I would like for you to do is to go through each step. So I'll say step 1, no, I don't have any fractions. Step 2, parentheses, oh yeah, I do. So how do I get rid of the parentheses? Use the what?
Distribute.
You distribute. Very good. So 3p is 3p.
Minus
3
15.
times negative 5 is minus 15 equals 25. So step 2 was get rid of the parentheses. Step 3. Do we have like terms? No. Okay, so we can skip over step 3. So I'm going to say step 3, no. Step 4. Get rid of the constant. Do we have a constant? And what is it? 3 is the constant here?
No.
What's the constant? Negative 15, the number that stands alone. We just discussed that. So we're going to say 3p minus 15 equals 25. So what am I doing with that? What inverse operation am I using? If I see subtraction, what am I doing with the 15? On both sides. Okay. Now, what does step 5 tell us to do?
Get rid of coefficient.
So what is the coefficient in this case?
3.
So what do we need to do with it?
You need to
What are we doing with it on both sides?
divide.
Divide. So how many times does 3 go into 40? That's something you figure out. Or is it a side or on a calculator in your head? But how many times? Because people think they're always looking for like whole numbers, and you're not always looking for a whole number as your answer. Okay? You need to be able to write an answer in a decimal form and a what? What else could it be? Decimals or?
Fraction.
Thank you. You need to be able to write in both forms. So 3 goes into 4 one time. 13 point what?
3.
Very good. Let's move on. So let's go through the steps again. Step 1, fractions. Do we see any fractions?
No.
Okay. So step 1, no. Step 2. Do we see any parentheses?
No.
Okay. So step 3. Do we see any terms that are alike?
Yes.
Right, so we're gonna say 3 plus 4.5 is,
Um,
7.5 Okay, so 7.5 m equals 15. Step 4, do we see any constants?
No.
No, so what do we skip to then?
Coefficient.
Right, step 5, get rid of the coefficient. How do I get rid of the coefficient on number 5? Timothy, I haven't heard from you. What do I need to do if 7.5 m equals 15? What do I do? Divide what? Okay, no, you don't take the m, you just say 7.5 because your m is going to be left there. So how many times is 7.5 going to 15? Think about it. Why don't you divide it? 2. Very good. M equals what? Very good. So now I want you to try the problem below on your own. And just like I wrote step 1, I want you to write step 1, no. Step 2, yes, or whatever, and solve. So that's what we're going to do. Take 2 minutes to solve the problem on this paper. Take 2 minutes to solve that problem. Yes, ma'am. Okay, so step 1, you said no. We do have to make that a 1, okay? Very good. Step 1, do you do step 1? So right now, we did this one. Okay, after you do the you try problem and we're not ready, because I'm going to give everybody like 30 more seconds to wrap up on the you try problem, go to the challenge problem so you're just not sitting there. All right, help me out here, people. Step 1.
no,
Step 1, no. Step 2.
No.
no,
Step 3.
No.
yes.
Yes.
Yes. What's step 3?
You
Like
put a
term.
bottom like
Like
term.
terms. So I have a 3a and a what?
A 1A.
A. A 1a. So 3a plus 1a is
4A.
Okay. So I bring down to plus 6. Now, what has the combining like terms done for us?
It's made it so we can, solve it good.
It made it where as though we have a what type of equation in? So now we can use our last 2 steps. Get rid of the constant. What is the constant?
6.
So how do I get rid of it?
Use the opposite.
Subtract what? 6? Okay, very good. So that's going to be what?
84.
Very good. Then I have 4a equals, so the next step is to get rid of the coefficient. Which number represents the coefficient?
4.
Okay, so 4 divided into 84?
21.
21.
Very good, 80 is 21. Okay, everybody try the challenge problem. After you try the challenge problem, we're going to go over that, and I need you to summarize today's lesson. What did you learn new today? What have you learned new today? What was today's lesson all about? So try the challenge problem, and then start summarizing. And right now, I just want everybody summarizing, so take your time to summarize the problem, the lesson for today. Yes, ma'am, you can do the rest. You want me to raise your glass? Thank you. Did you summarize today's lesson? I can look at your paper. Okay, about 30 more seconds to finish up. I'm interested in seeing, hearing about the problem, the challenge problem. I'm gonna write it on the board, and I'm gonna ask somebody to help me